No, it's for history. I will. Okay, I think what should happen is like all these groups. Yeah, but I think all the groups like come here, so their presentation will be yeah, right. Okay, I think it's good to go then. It works. Alright, take out the Slack channel. How are we all doing? Doing good. This is the right mark. Yes, it is. In fact, I just pulled it up too, but this is better. Y'all are one step ahead. And 15 minutes ahead. So I just got here. Thank you very much. Good to go. We should tell them how to switch over to we should tell them how to switch over to this. Or are we not going to be seeing I assume we're just hiding in the corner, and then whenever someone comes up, like, oh, you're this group, okay, we're with the one. That's what I mean. Yeah. All right, let's see. What changes were made? Okay, so that looks good. Nice picture, whoever put that in there. Maybe Biggie will do that side, I'm not sure. Meet the judges? Oh, yeah. You can just do this on your phone. You don't have to my phone. I don't know my own password. Yeah. Just you have to go on the YouTube page. But I don't have that logged in. You don't need to log in. No, we're just trying to figure the audio. Awesome. I am. Thank you. Okay, everything working, slides good. I don't care if it's not perfect. Yeah, yeah. I'm just thinking ahead. How do you think we're gonna pull up the team's presentation?
Just have to switch it. So how does that work? StreamYard, right?
Yeah, it goes here.
Okay, so have everybody text, say hello to all the teams, and make sure they send the links to you. So you just open the links.
We already have we did like
presentations.
The way we have it is they're already sharing their laptops. So just
okay, perfect. Oh, that's perfect. Yeah, that's why I like seeing.
Ryan Sharp,
What are you?
the AIM director.
Now say that with loud proud from your stomach. Hi everybody. Blah, blah, blah. Wow.
Got it. Are we good?
Yes, sir. Start recording.
All right, everyone, who's ready for the AIM night to begin? Thank you all for coming tonight. I am Ryan Sharp, the director of AIM, the Artificial Intelligence Mentorship. And tonight we are going to watch all of our amazing teams who have been working on their project this whole semester present what they have accomplished. I am so excited. Who else is excited? Yes, that's what I like to hear. Thank you all for being here. Let's get started with the introduction. Here's the agenda. Right now we are beginning the opening remarks. Then we will begin with the presentations. We have 7 or 8 presentations tonight. Then we will have a snack break and possibly pizza sometime during this. We'll figure it out. Or maybe not. We'll figure it out. That's what Lee says. And then closing remarks. Opening remarks. Let's begin. So what is AIM? Artificial Intelligence Mentorship. AIM is a semester-long program where UTD students, from freshmen to grad students, from all majors, can apply to this program. And then if they get accepted, they are put in teams which work on a semester-long project. And the project it focuses on AI and very often machine learning, more specifically. And we will see lots of examples of machine learning tonight. So in this program, the mentees learn foundational AI concepts, and each team has a mentor who is also a UTD student. The mentor has lots of experience with AI and probably some experience with deploying a product on the cloud as well. Because in AIM, we also focus on not only creating the AI project, but also deploying it onto the cloud. Why deploy something onto the cloud? Well, once it is on the cloud, there are more computing resources up there. So your program can run even better than it can probably run on your personal laptop. And think about it. Do you think the app Facebook is being run on Mark Zuckerberg's little laptop? Maybe not. So in AIM, we deploy our projects to the cloud where it can be used by more people and have stronger power. And the benefits of AIM is this might be the students' first opportunity to do programming in Python. They will probably, it will be the first time for some of them to learn these concepts of AI and machine learning and what these things are. You get to work in a team and you get to present tonight and you get to have a very fun time. What is AIS?
Okay, I'll come in for that. Hi, everybody. My name is Viggy. I'm the president of Artificial Intelligence Society. Our major goal and mission is to demystify AI. Right, we want to take away the uneasiness, the kind of fear that we all have, the little voice in the back of the head saying, you don't know this, you could do it, and get you involved in, get your hands dirty, programming AI and ML is like, it's going to affect all your fields, right? So we want that to be the forefront of what we teach. We do AIM. We're releasing some other program today with those closed beta once we get that here or after presentations. And basically our goal is to help everybody learn, grow, and learn machine learning AI. So it helps with their internships or whatever. But yeah, so we're doing hackathon next semester. Can't tell you the date or the theme, but you just know it's happening. And then next semester we'll be hosting more consistent events, like weekly Mondays and Friday tech talks, where we can talk to companies who use AI or machine learning in their companies, and then focus around research and industry. So you get to get both flavors. But yeah, that's kind of a brief overview
Love that. So I'd like to reintroduce Ryan and our mentors. Can we have them all come up, please? Give them a big round. So I used to be the AIM director, but now I want each of the mentors to say their name, major, how many years have been part of the program, what they did, what's their background, and then also what team they're going to be mentoring today.
Excellent. So I can go ahead and start us off. So I am Ryan, the AIM director for this semester. Last semester in the spring, I was a mentor like these gentlemen. And then a year ago, fall 2021, I was a mentee like many of the people in the audience today. And I am a senior majoring in data science, and I'm also going to get a master's in statistics at UTD.
All right, so I'm also Ryan, not to be confused with that Ryan. I guess it's
Your major, how long have you been in AIS?
okay. I guess I've been in AIS, I think since sophomore year. I am a senior computer science major. I plan on getting a master's in robotics somewhere. I'm figuring that part out right now. And I am mentoring the Twitter bot detection team.
Hello, my name is Rami Islam. I've currently been in AIS for over 2 years. I'm currently a senior computer science major. Current interest right now, I'm getting my master's degree in the field of natural language processing. Currently, I'm doing a project doing GitHub issues classification.
Hello everyone, my name is Nachikeet Devarankar. I am a master's student in UTD majoring in computer engineering. I've been associated with AIS since last semester. I was a mentor then, I'm a mentor today as well. The project we have been working on is video stabilization. How to get rid of all the shaky videos. That's the project. Yeah, happy to present in front of you guys.
My name is Jesse. I'm a sophomore in CS. I am leading the team that is making the resume grading and job recommended project. And I'm trying to get into the field of robotics, and currently I work on a self-driving car.
Hi, so my name is Eamon. I'm a sophomore majoring in computer science course, and I'm leading the team that is doing a project that's trying to predict whether a bill will pass and become law in the Texas legislature. And I just want to give a quick shout out to Ryan, because he was my former mentor last semester when I was a mentee. So this is my second semester of the program. And actually, Chris, me and Jesse were all on Ryan's team last semester. I just think it's really cool that we have that culture of retention and team building here at AIS.
Hello everyone, I am Richard. I am going to, I am a senior software engineering major, and I've been with AIM for 2 semesters now. Past, I was a mentee, now I am a mentor. So I kind of graduated in a way. And I am the team that's going to be doing YouTube summarization.
Hello, I'm Chris Shepard. I'm a junior CS major here at UTD. I've been with AIS for 2 semesters. Previously, I was Ryan's mentee. Since then, I did a couple AI projects over the summer just for fun, and I wanted to try something new. And so I'm leading the NLP project for Mindful.
Yes.
A huge shout out to the mentors who've been putting in hours on hours the last week, and I've been seeing their progress for a couple of weeks. They're doing really great teaching people from scratch. But yeah, thank you so much. Thank you guys.
Now, the people in this room, they're not only the mentees and the mentors and me and people from AIS and any other guests, but there are some special guests in the audience. The judges. Now, to be clear, there will not be any winners or losers tonight. There will not be a first place, last place, none of that. These judges are just distinguished individuals who have a lot of background experience in different fields, and they are here to ask questions and even give some feedback to the team. So, you all can introduce yourselves. You can stand up if you like.
Sure.
Everyone give a warm welcome to the professional.
Hi everyone, I'm Justin Goldberg. I'm the Senior Director of Programs and Operations. I manage the Blackstone Launchpad, which I'm sure all of you have been in a few times. And I handle all of our entrepreneurial events. I would love for any of you to consider submitting an application to the Big Idea competition. It'll be taking place in April of 2023. And we have a lot of events happening over the spring semester that will be there for us. So excited to see all your presentations today. Hi everyone, I'm Dr. Emily Choi. I teach over at JSOM. I think that is not clear up there, but yes. So I am Dryson's counterpart, so I do the academic programs, so the ones that you get a degree for. And I wanted to use this time to encourage you to think about getting a certificate in innovation and entrepreneurship. Vicky is getting a minor.
I already did that. It's an amazing program. I've been part of the institute for the last 5 years. I love AI, or at least as of that.
Yeah.
Club and all these, they're good programs if you're interested in moving up and not just working for fame, you learn, right? Where's Robin?
Yeah.
Mr. Facebook?
Yeah.
How was that experience?
That's great, actually.
So, so think about your futures, getting jobs, even just now, you're developing amazing products and implementing amazing technology. That's one thing, is to create great products, have innovations, but if you can't bring it to commercialization, articulate its use case in the real world and its value to customers, you go nowhere. So those skills of articulating your ideas into actual use and actual businesses is what we do over in JSOM. You can get a certificate in innovation and entrepreneurship. It's only 9 credits. That's 3 courses, and you start off with ENTP 3301. It counts as one of your preferred electives, I believe. And then you just pick whatever 2 ENTP courses, and then there's your certificate. It shows up on your transcripts. You can put it on your resume. That gives you a great edge when you go out beyond these 4 walls. And then the minor, so Vivian's on the minor. I think he said he's done with it. That's 18 credits. Again, you start with ENTP 3301, and you have a slew of ENTP classes to choose from. So yeah, so if you have any questions, you know where to find me. I'm excited for tonight. Good luck.
And in addition, I wanted to give a quick shout out to Dennis, because Dennis has 8 years of data science work experience, and he's now working at a startup as well.
Yeah, I guess. Yeah, I met these guys yesterday at the event that UT Dallas organized. So yeah, I spent 8 years writing machine learning algorithms and working for startups that put it in production. So if you want to have any discussion about potential career in data science, machine learning, I can tell you the inside scoops. What's going on there? Some of it is interesting, some of it is not as rosy as you think.
Thank you all so much for being here. Okay, so next we are very soon beginning the presentations. So each presentation will begin with a slideshow. They will present their problem and the project that they did to solve the problem. Then they will demo their project, and they might have an interactive demo where you can try out their project yourself. And then after the slideshow and then the demo, then there will be the opportunity for our judges to ask questions, and not only the judges, but anyone in the audience can ask questions during this time. Now, let's begin the presentations. Who's excited? Excellent. Can I please have the list of the presentation order? First, we have drum roll please. The first team will be Jesse's team. Yes. They will come up here. Okay, maybe they can figure it out. Let me. Thank you. Yeah. Okay, resume team. Okay. So, excellent. Thank you.
Can you go to the link in the thing and then just click share?
Okay. I'm the resume team.
Yeah, just like share your share.
Yeah, I'm gonna shoot.
There. Share screen.
Push it back.
Okay, great.
Speak loud, there's no mics, okay?
This one's someone.
Hello everyone, I'm Nikhil, this is Prateek, Alex, Raven, Harsha, and Mohammed, and our mentor Jesse. Unfortunately, Raghu can't be here today, and today we're presenting Reservoir.
Cool. So I'm sure all of y'all have made a resume at some point in your careers. Resumes are super important. They give you a way to both manage your education and all of your professional development opportunities in one single document. They're super important. You guys have probably made multiple edits, created tens or hundreds of copies of your resume over the course of your career, and probably have a lot of stress about how am I supposed to present it the best way? How are there any errors? Can I improve on any subjects or anything at all like that? Well, that's where we're introducing ResuBot. We have 3 features all bundled together into one application. We give you the ability to classify your resume into the best sector for it to be sent out to. We recommend currently available jobs to you that you can apply for currently with your resume that best fit your specific resume as well. And thirdly, we rate your resume on 4 self-developed metrics so that you know exactly where you can improve and what you need to work on.
So the first feature of our product is resume classification. This is where we provide the top 3 industries that the resume would be suited for. So for this feature, we used a Kaggle dataset with 2,400 plus string resumes along with their individual categories. For the data pre-processing, we applied a variety of NLP techniques, and as well as the main pre-processing we did was we combined some of the categories in the dataset to increase the accuracy of the models. Here's a histogram visualization of our dataset. Onto the models. So for this resume classification, we tested out 3 different machine learning models. The first model we tested was the logistic regression model, which had an accuracy of 67%. The logistic regression model is a statistical model that is used to predict the probability of certain classes based on some dependent variables. The logistic regression model maps predicted values to probabilities using the sigmoid function. The second model that we tested was the random forest model. The random forest is a decision tree algorithm that individually builds decision trees which each make their own prediction based on independent samples. And so the random forest model is similar to XGBoost as well, which had a 73% accuracy. The XGBoost model is different in that each decision tree is built one at a time. So they each improve upon each other, improve upon the previous wrong predictions, and improve the deficiencies of previous predictions. And this one had an accuracy of 73%, which is the highest of our 3 models. So here's the heat map for the XGBoost model, which shows that it performed best when it came to finance, banking, and accounting resumes.
Thank you, Mohammed, for the excellent explanation on our models. Next, we want to talk about our next feature, Job Recommender. If you look at the next slide, please.
But first, I want to reiterate why we make resumes. We make resumes to get jobs. Yes, it's true. With that being said, the resumes are our number one tool to introduce ourselves to companies, to show what we've done in the past, what we're doing in the present, and to give a glimpse of what we'll achieve in the future. So we have 3 distinct data sets. We have our resume data set from Kaggle, over 2,500 resumes. Our job data set, which we used Beautiful Soup to web scrape from Indeed, which gave us our job positions, our descriptions, the URL, and the job company. And then we also used our LinkedIn skills. Our LinkedIn skills are over 30,000 skills and tools that LinkedIn says, hey, these are the most prevalent in all industries. And then we found the intersection between all of those, and we use what we call a TF-IDF count vectorizer. And that is essentially a count vectorizer that has the word frequency for each individual job posting. And then we use the same pre-processing for the resume that is passed, and then we compare it to each individual job posting to figure out which one best fits your resume to give you the highest chance to land that job, the job that you've been building your skills and your experiences for. And with that being said, I do want to pass it off to Hershey for the next segment of our presentation.
Thank you, Raven. I'll be going over the resume grid. So for resume scoring, we'll be looking at these 5 features. So for word scoring, we'll be looking for the use of strong action verbs, especially at the beginning of both ones. For quantifiable data, we'll be measuring the number of numeric values to measure the impact scale and improvement metrics of your resume. For grammar, we'll be using a language tool library to score. We'll also be looking for the average sentence length of your resume. We'll also be looking for certain requirements like skills, GPA, and education.
Cool, so now you guys know what our app is supposed to do. Let's talk a little bit more about how we actually built it. Go to the next slide. You can see this is a kind of simplified version of our AWS architecture. We created our backend on Flask running Python code, and we created our frontend using a React.js. We put all our frontend files on one S3 bucket and all the backend files on a separate S3 bucket. We then used AWS CloudFront to navigate all of our HTTP and API calls to an Elastic Beanstalk application. The EB application pulled directly from our backend source file, and that's where all of our Flask app is running. We then used an Amazon EC2 instance to run our application on the website as a whole. Finally, we used Elastic Load Balancer to make sure all the requests and calls were routing the right way, and then we had all the required security measures in place.
Thank you, Pratik, for that great explanation of our AWS pipeline. Throughout the 10 weeks of this app's development, we faced some pretty notable challenges, and I just want to mention them briefly. So the first thing is that most of us have not done any AI projects in the past, so this is going to be our first one. And what that means is we had to do a lot of learning before and during the development of the product. The second biggest obstacle for us was collaboration. Our team is 7 people, so it's kind of like a bigger team size compared to all like the class projects that we had to do. So we had to really lock in our scheduling so we can meet regularly, as well as leverage Git to aid in our program collaboration and version control. And lastly, but probably the biggest problem that we had to face was the fact that we had to connect all of our multiple features. As you can tell, we have a lot of different features, and we developed them all in parallel. That just means that at the end, it was kind of a really complex problem to say, hey, let's get all these separate features, put them all together into one cohesive product.
Thank you for that, Alex. Now on to what's next. In the future, we hope to give more descriptive feedback on resumes. Currently, right now, we have the code displays a total score and subscores for each resume. We hope that later in the future, we hope to get further into the scoring by allowing the user to go through each line and figure out what's the problem for each line and figure out how to solve it. Then we also hope to fix the UI by adding light mode and fixing the UI in some cases. And then we also hope to add user accounts by adding a database. That allows the user to insert their resume and allow them to save the resume on the website directly. so they don't have to upload the resume every time they access the website. It's simple and it's efficient. Now, onto the demo. Okay, so here's the front page, and it's our little mascot, Resume, and it follows your cursor. And then, if you press get started, you're then sent to this screen where you have to input a PDF file. And we'll submit this one. And then here's what the layout is. We try to get the functionality of Grammarly and Resume Worded while also having the same style of Duolingo and Quizlet. So on the left side, you have the resume that's entered, and then on this side, right side, sorry. And on this side, you have the overall score, which shows and the breakdown for how the score is calculated, and for each subsections of the score. So for example, the grammar score, the numeric score, the resume requirements, and the word score. And they give a small section that describes, how far you are in your progress in each section. So as you see, this is the score. And then if you want to input another resume, you go and press new resume, and then you input one. So then here you have it, the new scores too. And then if you want to go to the job selection side, you press switch mode. And then here you take the job categories, which shows you the top 3 categories that your resume would do best in. So for example, this would be engineering, marketing, business, and HR. And if you scroll down, you get the recommended jobs. And they show all the best jobs for you. And the jobs are best that your resume is best equipped for. And if you press apply, it'll take you directly to the link that allows you to apply. And then also, it is also responsive, so you can adjust the screen size and it'll adjust to that. And just for one more safety measure, just to make sure, it doesn't work only just for CS majors, we're putting a fitness major's resume in here. And here we have it. Resume Log makes your resume grading, resume checking simple, easy, efficient, and also fun at the same time. Thank you. Thank you. Oh, any questions?
After it does the scoring in the paragraph area, is that going to give each resume some ideas for improving what they have, or is it just general comments? Like, are you giving the person who uploaded the resume specific feedback on how to improve their resume, or just scoring it as it currently is?
Currently, it's just general. We hope later in the future, we hope to go more in line and allow the user to find out the specifics for each of the sections.
We kind of implemented it for the grammar school on the top. You can see like some specific sentences that needs to be improved the most. That's different for each resume, but for right now, that's the only one that has that.
Okay.
We definitely have the capacity to do. We hope in the future to do inline, where you can hover in and go to each line and find where the corrections.
All right, this is great, very neat. How did you come up with the idea? Are you guys on the job market and you thought it was too manual, or did you?
Actually, I was the one that pitched the idea. I'm the mentor, and my idea was I'm a sophomore, so I was trying to get my first internship, and I know the pain of having to write resumes because I have 50 million different resumes on my laptop.
Yes.
So I was like, I want to make a tool that will make that a lot easier, especially for college students and people that don't know. It's like they're making the first resume and they want to get an internship. So that was my idea in making this project.
Okay, that's awesome. And as everyone's human here, right? So everyone has some kind of problem they've identified, and being human, you immediately think of an idea to solve it, right? This is cool, this is exciting. So what the next step is are there other people like me that has the same need? Is what I'm gonna spend a lot of blood, sweat, and tears building, is that actually gonna be desirable for a bigger market, right? This is over in 3301 is what we try and take you to the next level to think about and to do research around. And then if there are others, how big is that market? And, you know, that involves secondary research, oftentimes. And then I can't be the only one with this amazing idea, so who are the competitors? How is my idea and my design better than what's out there? And so altogether, this creates your business model, and then your go-to-market strategy, and et cetera. So I love to see now how this can connect to a class over at JSOM, the ENTP classes. So I hope to see you all in class. Okay, so here are my questions. All right, so I just gave a plug for ENTP. So a lot of the data that you get in from those 2,400 resumes, you use as fodder to build your intelligence to recommend or to score. How are you certain the input is good? Because as you know, bad data in is bad data out.
Okay, so firstly, we use like a pretty reputed data set from Kaggle, so we have like a pretty good idea that the data would line up well and would have like the right amount to like make sense basically. But then we also pre-processed the data. A lot of the pre-processing was removing data sets that like didn't match up, had null values, or things that like would impair the way that the model learns. Specifically, data sets that like didn't match up with the predictions, or had extraneous rows or columns or stuff that wouldn't fit into like the right table for the machine learning.
Okay. So you're using historical data to predict future jobs.
Right.
You see there might be some mismatch because times change. So think about how this is AI, how do you ensure that the match to future jobs are actually a match to future jobs when your basis of information is historical?
Yeah.
So, yeah, okay.
I can go ahead and discuss about
Sure.
that. So we go through an arduous process for pre-processing.
Yeah.
We have 3 different data sets that we try to pull the software words, and all of them are very lengthy. 30,000 skills, 2,400 jobs, and our web scraper that we implemented, we go through Indeed, and it constantly updates our data frame.
Okay.
And so we're allowed to, so if you go to any of the job recommendations, they do have work with, and none of the jobs are.
Okay, that's great. Now, what would also be great in, so when you go to, so Dresden has a great idea of like, would you also recommend better wording or better ways to rephrase things? I have a similar question about like the job fit, or what's the other one? Yes, this. What if you think you created the best resume and you want to go into digital media sales, but somehow everything you've done in the past, it relates to arts and fitness. So your tunnel stuck, yeah, that's a good word, into an arts and fitness career. Could it also likewise recommend you might want to reposition this job that it has more sales bent to it, even though it was being a trainer or something, right? That could be another good additional feature. Yeah. So if you look at my resume, I get jobs to be a production an operations manager, because that's my field before, but I'm in the field of education. So I would be definitely misplaced if I were to use your algorithm. Okay.
I just have one other comment. The presentation was really good. I felt like I could easily follow everything you were talking about. It wasn't too technical. I mean, there were a few words in there maybe that was a little iffy, but I think another thing that Emily asked right at the end was how you came up with this idea, and that's always a really good thing to incorporate in the presentation because it emphasizes the pain. Like, this is what we were dealing with, and this is why we decided to develop this. So that story piece is a really good part.
Yeah. Otherwise known as
the
the
personal story.
Yeah, the personal story. Otherwise known as the hook.
Yeah.
Yeah, you want to hook in your audience, like, yeah, I know what you're talking about. Haven't you all felt the pain of developing 50 resumes? Yeah, you know. But great job.
Excellent.
Yes,
Yeah. All right. Can I have another drum roll, please, for the next team? It's David's team. Yes.
Let's see, which one is the
Share screen. Did you spin it? Yeah.
You would like that expensive? Excellent.
One point in having Jesse was great.
Is there anything else I need to do?
Okay. Maybe I can sit back there.
All right.
We're good? So this is your session? All right, excellent. All right, y'all. Are y'all waiting on anything, or should I try and get their attention? All right, everyone, give a warm welcome to Eamon's team. Thank you.
TGIF? No. Texas Government Information Forum. Now to meet the team.
Hi everyone, I'm Nevin.
Hi, I'm Savell.
Hi, I'm Sophie.
Hi, I'm Marcia. Hi, I'm Anne.
Hi, I'm Megan.
Hi, I'm Erica. Hello, I'm Karna, and this is our mentor, Eamon. So, according to the professor at Michigan, C.K. Pahala, strategy is about stretching limited resources to fit ambitious aspirations. And a lot of those ambitious aspirations can be solved through our legislation. Unfortunately, to gain insight into those legislations can be extremely expensive and hard to obtain. But they pay off big. Return of lobbying expenses for top Fortune 500 companies is $1,000 to $1,000. But I, the average Joe common man right here, if I want to support a bill, it's a lot more difficult for me. I don't have the resources those companies have. So let's take a look up here. Bill 1, all new vehicles must be electric. Bill 2, only new commercial trucks must be electric. I love both bills. But you know what? I think I'm a little bit more leaning towards Bill 1. But no matter what, as Mr. Average Joe Man, I can't just pick one. It's like taking a shot in the dark. So we decided to build a model that would predict which bill has a higher chance of passing in the House, so people like me can put our efforts into something. As we can see, first bill only had a 15% chance, while the second had a 70%. Now I know where to put my efforts and resources, and just like those other companies, I know what to do, where to take my next step.
We sought to create an accurate tool which provides legislative insight. We made a tool that's accessible for the people, reliable so that you can depend on it, and unbiased so that you can trust it. We seek to provide nonpartisan, equitable, and reliable legislative insights to all organizations and individuals. To implement a solution, we split into two teams. The machine learning team who contextualize factors such as the number of authors per bill or who is proposing the bill. And our second team is the natural language processing team, who use bill text as their data.
And now for a deeper insight into what the machine learning team had to do in order to implement our solution. So the very first thing we had to do was find and scrape our data, which we achieved by using Python requests and beautiful soups to find out features for our model. The features we came up with were the author, the number of joint and co-authors, number of subjects in a bill, gender breakdown, and party affiliation. So after we found and scraped our data, we conducted an exploratory data analysis. So this informed us of what we needed to do, decisions we had to make in order to design our model. So the data on the left is going to be a histogram, which conveys the total number of additional authors, which is a very right-skewed histogram. On the right, you can see the total number of subjects, which is a slightly right-skewed diagram. This data is useful to us. However, we need to normalize and standardize it first in order for us to use it for our model. The second exploratory data analysis that we conducted was over the Senate party and affiliation over time and the House party affiliation over time, respectively. And then, as you can see, the data for both of these graphs are they have little variation, which convey to us that this data may not be as useful for our model, so therefore we wouldn't use it, as it would not help our model predict whether or not the bill would pass.
Some additional exploratory data analysis that we conducted is a line graph of the trend in the increase of female senators over time. As you can see, for the diagram on the left, from 2002 to present time, there is a steady increase in the number of female senators. This is interesting to see how the increase in female senators affects what type of bill that passes or the number of bills that pass throughout these different legislative sessions over the time.
So after performing our data analysis, we started to build our model. On the ML side, we used a deep neural network to build our model using Google's TensorFlow API. We used 256 input variables to produce an output to make a prediction about whether the bill would pass. Along with building our model, we also used batch normalization to help our model learn faster and be more accurate. And after building the model here in this matrix, you can see the results. Currently, as you can see, the results are not very accurate, especially in the pass column. And so we would like to fine-tune our model. To fine-tune our model, we would increase the number of features, consider down or up sampling, or change the model architecture by analyzing if the model is currently overfit or underfitted.
So now the natural language processing team is going to explain our process and how we came to build our model. So to begin, we loaded our data from the government server so that we could have the bills to analyze. We downloaded those PDFs, and we had a separate PDF that helped us generate what labels to use, which is very important to us when it comes to categorizing later. And finally, we used a PDF miner to convert those PDFs into text. So when we converted those PDFs into text files, it created an issue. Basically, as you can see, there are a lot of garbage characters at the backslash ends and the random commas, and so this would have made it hard for our model to read the data. So we used regular expression of Python in order to clean our data, which later made it look like this. And then we also utilized regex to make all the data lowercase and to take out all punctuation just to make it easier for our model to read. And so after we had our data, we performed exploratory data analysis. And so as you can see from this graph, it shows the average number of words in each bill. And so clearly the data is very right skewed. And so knowing the median and the distribution is good because it can help us to create or to choose the optimal max word length in order to encapsulate the most information using the least amount of resources. And so this is our pass-fail ratio. And as you can see, the pass-fail ratio is about 1 to 4. And so this could be challenging because it creates a problem because it kind of makes our data a little bit imbalanced, and it just made us have to train our model a little bit harder.
For our model, we use an LSTM, which stands for long short-term memory. It's a type of
Recurrent neural network.
Recurrent neural network that takes in past outputs and uses them for current inputs. This historically performs well for NLP tasks for speech processing. This is a confusion matrix that models our initial LSTM model. The model had a high accuracy of 80%, only because the number of failed builds was overrepresented. Say you've taken a model, say you have a model, right? And it predicts a lot of fails. It will give you a result of 80%, which can be extremely misleading.
So to deal with this problem, we had to go ahead and downsample our data. So for example, right, we have 4 bills that would fail, and 1 bill that would pass. Model predicts fail every time, 80% accuracy rate. So to fix this, we changed that ratio to 1-to-1 on bills that failed and passed, and trained our model on that, and that fixes this problem. And so then after we do this, we still have a model that's overfit to our data. You can see on the graph on the left here, the accuracy continues to increase, and then our validation accuracy starts to plateau. So the model thinks it's getting more and more accurate, but the real world accuracy is staying the same, and that's a sign of an overfit model. And you can see that on the loss on the right. The loss continues to get lower and lower, and that's what you traditionally want, and that's what you traditionally want in a model, is where the loss decreases, but the real world loss, the validation loss, is increasing. So this is how we started to combat that overfitting.
To combat this, we already implemented dropout and weight regularization. We want to try to implement and either expand the data or using a less complex model structure.
So now we have a little demo for you guys. It is just locally hosted here, and the future goal is to get it all into the cloud. So we talked about the 2 models, the ML model and the NLP model. This is what uses the ML model, that deep neural network. We can look up a past bill and see what our model would predict for it, or you can enter in your own features about a bill. And then we have our separate one, our NLP model, where you can go ahead and paste in text of a bill here and predict it. So I have 2 bills to use as an example here. Here's a bill. This is a website that just displays bills, the same data set that we use to grab all of our bills. House Bill 4175, bill from 2015. So if we go ahead and look this bill up here, we enter in the legislative session, whether it's a House bill or Senate bill, and the bill number, and we just need to make a prediction. And our model predicts this bill would have about a 45% chance to pass. That's not including any of the text data. That's just the data around it with the committees that it's in, the breakup of the legislative session. So you get 2 separate pieces of insight. This bill did end up passing. So let's go ahead and look at what our NLP model does with the text of the bill. Just access the text of the bill here. And all we need to do is copy and paste it over. And then we get a separate prediction of 79%. So you can see the text of this data is very strong towards being passed, while it's less strong in the other factors that surround it. But that was a bill 2015. It did end up passing, if you see here. It was sent to the governor and it was effective. But let's look at a bill that's introduced in this current legislative session. This is something that was filed November 14th, hasn't been seen yet, and we'll see what our model predicts. So to give you an idea, this bill is relating to the adoption of the agreement among the states to elect the president by a national popular vote. So we'll see what the Texas legislature thinks of that. So we can't look up this bill because it's in the newest legislative section. So we go to this section here and enter in the information. So this bill is going to be a Senate bill. It doesn't have any joint authors or co-authors, just one author, and it has 2 subjects. And then you need to select the committee here. So this gives you a list of all the Senate committees. If you had a House bill, it'd give you a list of all the House committees. So we need to put this in a committee. There are multiple options, but for now, we'll just go ahead and put it in local government and make a prediction. So with just those factors around the bill, as well as a ton other that's scraped about this current legislative session, data is scraped for you, so you don't have to enter everything in. It gives it a high % chance to pass. But we have 2 models here. So what does the text tell us? So all we need to do is copy it over again. And then you see it really doesn't like the textless bill, giving it a 1% chance to pass. So you get those 2 separate pieces of insight there. This bill, almost never likely to pass. That's probably because bills like this have been pushed before to try to get Texas to enter that coalition of states to join the national vote. And the models recognize that and says this will almost never pass. But if you're just introducing a bill in general into the state government committee and it's a Senate bill with this current legislature, it has a good chance of getting out of committee. So you get the duality there. So that's what we have now, but we have plans, future plans for this project in 2 phases. The first phase is to get everything off of being locally hosted and put onto the cloud, put it onto sources like AWS, where you have more resources to train the model, make it more in-depth, and then from there, you can easily deploy it to consumers, and then combine both the models into like one UI and front end.
And then phase 2 of our implementation would to not only have a bill passage model, a predictor model, but also to integrate it with relevant news articles and snippets to make a more seamless and worthwhile experience for the user. Thank you for your time and TGIF. And we'd like to open the floor for any questions and comments.
Wow, yeah, it's great. I'm really excited to see something like this, being developed. I think that's really cool. I do want to mention that the Blackstone Launchpad has a nice resource with AWS credits. So if you do ever move forward in developing this project and you need credits for AWS, you can support in that. But great job.
Thank you so much for
You
that.
get a really great hook. That was great. It's a good opening. All right, so essentially it would be great if you talked to a political scientist researcher and ran this by, got some input and suggestions on how to improve your model. Political science, like any social science, the researchers are looking at what X variables affect the outcome variable Y, right? And so it sounds as though you guys collected 256 inputs, 256 variables. Did I get that right? Yes. And so you regressed all that onto a bill being passed or not. So it's like a logistic regression in the background.
Yes,
right?
and that's just the data surrounding the bill. Then we have a separate model for the text of the bill.
Yeah, so one model works on the things around it, which is what the ML team was in charge
Yes.
of. And then we
Focus on the text. Okay, so it'd be really good if you could clarify every variable, and then see what is actual significant effect on the outcome variable, right? And then you can be more parsimonious with your model and hone in exactly what is predicting the actual outcome. And I would say that getting past data is probably good and is good because this industry of creating bills is probably has certain ways to wrap words around it or way to be written. So it's going to be probably a reliable way going into the future. So yes, try and find more parsimony in this logistic regression that you're essentially building, and so that you can have more understanding and more like the levers that actually affect a bill passed or not. Then of course there's going to be external environment that play into this factor of a bill being passed or not, right? The climate, the current, going on with the economy, the social sentiments, all that. So I think that's where a political science researcher could also help guide you. About your sampling method, you called it downsizing. Actually, the best way to do sampling is really important. You want unbiased and randomly selected bills to build your model off of. Otherwise, if you downsize, how do you know there might be bias in the actual data? So when you, I would recommend go back to your population of bills and randomly select a balanced, set of pass versus not pass, and then go from there again. Yeah, all right? All right, thank you. Very good.
Any other questions? Yeah, anyone else? Questions, comments,
As
concerns?
for sampling, guys, there are two simple ways to solve it. First is the metrics you use, you can add weights to the metrics, and you can say this negative population has higher, lower weight, positive population has higher weight, and you'll get rid of the bias in training, or you can oversample. Like you can just repeat the data multiple times because models are stupid, they don't know the data, but if it appears multiple times, it will pay attention more to it. So that way you can balance it out without losing any information.
Yeah,
Thank
yeah,
you.
there's this whole method of propensity scoring that you can get, address endogeneity of your sampling. Yeah.
Well, thank you guys so much.
Thank you.
Great job, everybody. Proud of y'all. All right. All right, everybody. The next team is, drum roll please. It is Nachika's team. Yes. Oh, there has been a modification in the order. The next person is Richard's team.
Yes.
Do you need to look at this?
No, I can get off here. I just need to present them.
How do I do this?
Yeah, at the bottom, it should say present.
I already did that.
Oh, is this one yours?
Yeah.
Oh, then I got you. This one now? This one?
Yes.
Perfect. All right, you're all good.
How do I advance it? How do I advance it?
Oh, just like,
we
as if
deal
you're doing
with-
it here. Just like,
Hit space.
Sorry.
no,
sorry
don't
to-
worry about the slide. This page anymore. It's just wherever you were doing it previously.
All right.
All right. Okay, now I can start. So we deal with video summaries, and we are with some. First, I'd like you to meet the team. Next slide, please. There we go.
Wait.
Okay. Our mentor, Richard, and then we have Abyss.
My name is Abyss. My name is Sam.
I'm Kuma.
I'm Jackson Huffsettler.
And I'm Jonathan, and we also have Cosplay, who was not able to be here as well. So our problem with there we go. Our problem was to identify where we can save time while studying. For most students and many people, right, they want to study a lot of concepts in a very limited amount of time. And that's one of the reasons that we have this solution. Our solution is VidSum, which we move to the next slide. And now, why would we want to use VidSum? The first reason being, it saves a ton of time because it gives us a summary of the video that we're looking at. It could be 1 hour, it could be 2 hours long. And we could get a small summary from that video so that you'll be able to understand an overview of what's happening and what the video is talking about. And with the summary, you'll also be able to understand the concept that you're learning in a much more efficient manner so that you'll be able to understand and perform well in your exams and your future endeavors. And next slide. So our target user is not just students, it's also researchers and people who want to learn more about just any concept in general. And if that video is online, they can go to VidSum and get that summary and get it done with, and they can learn it in a very efficient manner. So with that, I will pass it on to Sam, who will be talking about the UI.
Thank you. So for the user interface, the main goal is to make a simple and sleek design. Do you mind moving to the next slide? Thank you. So a simple and sleek design, we just want the user to click on the Chrome extension and just be able to summarize it really quickly so they can continue studying effectively. The technologies that we use are JavaScript, HTML and CSS, Python and AWS. The main use of JavaScript was for the input handling. For HTML and CSS, that was for the design.
And then all the data that's on the front end will be sent to Python and AWS for further processing in this project. And now I'm going to pass it on to Kuma, who's going to talk about language model.
Okay, so for the core of the language-based products, choosing a decent or good language model has always been the top issue that we're facing with. So for the fast performance, we have passed several different types of model that you can see on the screen, like DistillBart and GPT-J and GPT-3. Those are some of the most prevailing models that matter in research field of study or business use case. So we finally choose DistillBart as our option because it's highly skilled in summarizing the long-form content, which is matching to the need of our target customers. No matter it's a long business talk you don't have time to spend on, or it's a video lessons for your last minute study for the midterm. So what's better is that it's lightweight compared to the other two, which means it runs fast and it's easier to deploy. So speaking of the software engineering and deployment, I'm going to pass the topics down to one of my teammates, Iman.
So we use the notebook to launch the model, and the API interacts with that. So I'll pass it to Abyss.
Next slide. All right, so we start off with a YouTube link, and the YouTube link goes into the YouTube transcript, and it gives us a transcript. And then after that, we go into a gateway, and basically an API gateway is just kind of like a communicator between the input and the output. So you take the input and you go into the Lambda function. The Lambda function goes ahead and calls the endpoint, and the endpoint communicates with the model. And that's when, after the model, we go into actually getting the summary. And after that, you have a couple of returns. You get back to the gateway, and the gateway outputs it to the user and allows them to look at it and also select a rating. So for a more simplified version, you essentially start with the Chrome extension. You click summarize, and that goes to the gateway, goes through everything, comes back out, gives you a summary, and you're all set.
With any project that you may be working on, especially a project that needs to deal directly with the real world, errors are bound to crop up. Some videos may not be able to have transcripts that we can extract. Some videos just may not exist at all. Well, sometimes everything just goes perfectly, but server goes down. Anything can happen. So instead of avoiding errors, we decided to directly deal with them with a very unique model. Here we have a success track, and here we have a failure track that the data always goes down. And we always switch into the failure track anytime any sort of error happens. And this underlies our entire backend. This guarantees that no matter what happens, no matter what day, no matter what error, we will always be able to handle any error that may crop up, no matter what it may be, no matter what may appear in the future, or what has happened in the past. Now, to demonstrate this, we have assembled for you a little demo. So switch tabs and presentation.
Can you guys not speak in the back or take it outside, please? Because I can't focus here. And you guys are probably getting disturbed too.
Can you all reliably see this? Oh no.
I'll have to switch it. So I can't see too well. Is it this one?
Yeah, I think so. Yep. Now can reliably see this. Okay, good. So here we have a video about neural networks, but it's 19 minutes. Perhaps we want to just watch that in a little bit short amount of time. So we pop open our extension here, and we click the summarize button. And it's currently loading. Give it a second. Again, as we can see, it pops out a short summary of the video. Video is succinct. We can read it in a few seconds. Meanwhile, the video would take an entire 19 minutes. Let's check another video. A live demonstration of some music, 18 minutes, a bit long. Perhaps let's try to summarize that one. Forgive me. Oh, what did you look at that? The transcript is not retrievable. That an error has occurred. But as we can all see, it all still works. I can still go back to the original video. As for a transcript, nothing is broken. Everything still works. It is very error compliant, no matter what may happen. And of course, we get a pretty good summary.
Okay, good job.
So now, I think it's time for questions. If you have any.
All right.
This. It's the AIM2. Yeah, go back to slides.
I like that you think about the errors, and you integrate it into your solutions. That's great.
So I have to demo
this
each
is like Cliff Notes for videos. Do you guys know about Cliff Notes?
Yeah.
Okay. And I'm like, oh my god, do they not know? Yeah.
Yeah, it's perfect.
Doesn't YouTube already have something like key moments in video and kind of describes, like, isn't that already summarizing?
Well, for YouTube, those are more highlights of videos. Therefore, if you want indeed the important bits of videos, you go on a bit long. But that's not suitable for every video. If the video is more instructional, where the content is important throughout the entire span, there is no highlight to focus on. In that case, our solution is more viable.
And usually YouTube videos are also based on timestamps at those specific moments. We want to have it for the entire video all at once.
I'm trying to really think if this is a valuable solution. Like what, I get the whole problem that you painted, good starting point. But is it a really big problem? Is it really painful to watch videos? Aren't videos fun?
Okay. They will be fun if the person who's teaching, they have like good objects and the pictures to help people learn. But it wouldn't be fun if they just go on rambling about the subject and the different topics, you know, and formulas and all that. But that's why our product is much more viable, because it helps the user who wants to learn more about that overview of that concept. Just to understand what's going on, what do I need to know, what are the main topics, what are the main concepts that I need to get from this video. I don't want the whole thing, I just want the main concepts, I need to know what I need to research on.
It is specifically for users who, as he said, do not want the whole thing. Of course, if you do want the whole thing, you can indeed watch the video. It is a small interest to a lot of people, although small interests are there. Small interests should be addressed.
So your target, or this is applicable for videos from people, for amateur video makers who, because I'm thinking of like TED Talks. Those are great to watch. I don't want to summarize. I want to watch the whole thing. 20 minutes is it's well worth it on a TED Talk, that is. But then you're right, there are some videos that are like posted, like how to use Excel and how to, these, and some people don't make really great entertaining videos. So I could see it there. I could also see maybe another feature is you could do like a comparison or show like which presenter of how to using Excel or whatever it is gives a better presentation. And then as a user, I was like, and you tell me which one's better, and then I'd watch that particular person in full for all the details rather than the other person. And I save time because I don't have to go through both bad videos, right? I'll just go for the least worst video or the least bad. Anyway, all right, that's my 2 cents.
Thanks so much.
Yeah, so if learning is the primary objective of this, is it possible to use the tools that you've already created to maybe like create a longer form, not exactly a summary, but if you ever remember in class, like in middle and high school, if your teacher would give you guided notes, would it be possible to like create, using the tools that you have, like a program that essentially creates like these outlines of guided notes to keep you more engaged and retentive to video content?
We absolutely can. In fact, those can basically be described as the same content. Because of how how we structure the API in our backend, we can effectively use the same model that we use for those 2 different purposes. So if we can create another extension, which is clip notes from teachers instead of videos, and we can use our same infrastructure in no time flat.
What is the max video length that works on this tool?
For now, it's 2,000 words, but I think Rami had like a better model for us to use, but like we ended up not being able to use it yet. But like basically, there's like we can have different models and like maybe expand our app to like include the bullet points or include the question generation, or like include something that like, you know, like a user might want that's like not within the scope yet. So yeah, I think, yeah, the answer to that.
Like one question. So you heard about the new GPT Instruct model. So I was wondering, like, is there any plans for going to use it in the future?
GPT Instruct, you said?
Yeah.
I was thinking about using it, but it was not out at the time. So then we just stuck with the Distillabart model for now.
In future, we do plan. On future, if we were to continue on with this, we will train our own model using data generated from user interaction with it.
Yeah, with the.
My personal plan is to create a recurrent neural network that can handle handle videos of any length.
Any more questions?
Thank you for
Thank you.
We have the cheapest team.
The black and
Did you share the things? Are you on the page for this? No. It should be in the Discord, but if you click the link, not the Discord, sorry, Slack. Yeah. And then once you get it, say like present, you just share your screen. Mute myself, man. Yeah. So, yeah, it is. You should screen. Just share your screen. You're good.
All right, good afternoon, everybody. Today we're going to be presenting our project called Stabilist, the Fabulous Stabilizer. My name is Rayon Noor, and I'm going to be introducing our team.
All right.
Okay, this is Dan. I'm Daniel Morandi. I'm Neil Agarwal. I'm Ajay Kumar. I'm Kamal Jana. I'm Sudesh Ishwar. And this is our mentor, Nachika. Okay, now with the rise of smartphones and technology, a lot of people are recording a lot more videos more often, right? But then there's a slight catch. With a lot more videos and easier to record it, we end up getting shaky videos. Like, you know, when you're running after someone or you're just trying to hold the thing, right? And it's a little shaky, like you can see over there. It's an exaggerated example. But now you have a shaky video, but you want it to actually be clear. There are a few current methods to do this, but they are very expensive. For example, you need to have like a professional editing software like Premiere Pro, which is pretty expensive, and nobody wants to buy whole editing software just for stabilizing video. Or to get stable videos, you would also need the latest technology, such as the new iPhone 14, which they record the video stabilization features with. which a lot of people don't have because it's just simply quite expensive. Or if you wanted a cheaper alternative, you need to have a gimbal with you, but that's pretty inconvenient to carry. And sometimes you want to be recording videos on the spot, right? So you're on the, oh, I need my gimbal out, you know what I mean? So what's it called? This project you have here will be a solution to all of that.
So basically, what is Stabilis? Stabilis is an intelligent program. Its sole purpose of stabilizing footage. It does this by like dissecting the video into individual frames and then assesses each frame and then improves it individually, providing the best video possible.
During the development of Stabilis, the team was motivated to achieve 3 different principles. First, adaptability, to take any kind of video and bring it into the 21st century. We're here to renovate old, shaky home videos and make it a better memory than you remember. Second is accessibility, to provide video stabilization to anyone. Regardless of your tech, we're aiming to provide best-in-class service. And third is the ability to build on what the market already offers. Simply put, we're working to produce the best video stabilization. So today, leading players in the video stabilization field use 2 methods to tackle the issue of shaky video. They either zoom in and compromise the content as seen on the left, or they add black bars and ruin the user experience as seen on the right. We don't want to mess with users, and we would hate to compromise content, so we developed Stabilis by avoiding these methods.
Okay, so how we basically did this is we took a data set and we split each video in the data set and we transformed it to fit our model. We then uploaded it to AWS SageMaker where we were able to train the model. And then we intend to deploy our model using Flask and REST API, and then we would intend to create basically a web interface or app that any user can use. So the data set we use is called DeepStab. DeepStab has 22 videos of both shaky and stable videos. So like as you can see on this first area, there's like a shaky frame of a fountain, and there's a stable frame of a fountain. So basically this is the data set we use to kind of train our model. Each of these videos range from like 8 to 30 seconds and have at least 200 to 1,000 frames each. That's kind of our data set. So our first approach to this was stable diffusion. The stable diffusion basically works by adding like Gaussian noise to each image and then basically training the model to denoise that image. Like as you can see here with the cat image is certainly getting more pixelated or like more noise being added to it. We would then train the model to denoise that image. So then unfortunately, there was an AWS hardware problem. So the one that we were working on, the machine, it ran out of RAM. So we couldn't exactly train it if there's not enough RAM. So, but we couldn't upgrade to the next machine because of lack of funds. So, and also we couldn't really like figure out how to decrease the amount of RAM we are using because of the minimal documentation, because stable diffusion is pretty new.
No cats were harmed.
All right, so now speaking about the magic that we use to make this possible, we use something called GANs. And what GANs are basically a game of tag. You have 2 players. You're gonna have the discriminator and the generator. The goal of the discriminator is to catch every false version of what we want the result to be, while the generator's goal is to create something that the generator cannot catch. In the end, we play this game back and forth, which is called an epoch. And in the as a result, those epochs go from 300 to 300 plus epochs or the game. Now, moving on to the architecture, we can see here we have one for the generator and one for the discriminator. I am not explaining all these numbers, all right, so do not worry about that. But as you can see, it's labeled and it says layers. So GANs are a neural network, and neural networks are like onions. They have layers, right? So the idea is that you're gonna have a data set and it pinball machines through the layers until we get the final result we want. Now, as you also notice, we don't only have the discriminator as a model. We also have to train the generator, and the generator is trained by using stable images and it basically knows, okay, this is a stable image. Everything else I'll consider as unstable. All right, and lastly, for the training is the question, right? So how do we go from video to video? The answer is we don't. We don't go from video to video. What we actually do is that we cut up the images frame by frame, and each of those frames are looked at to compare between what a stable frame looks like and what an unstable frame looks like. These are trained multiple times. Like I said, we ran this for about 300 epochs using AWS within our limit. And in the end, we were able to convert the images into the stable images that we needed, and then put them back together into the video. And that's how we make the magic happen.
Okay, so now we're gonna show a quick example of how our thing would be used. So give me a second. So we weren't able to create a website, but we do have a best example of how it would work. So say you take this example unstable video. So as you can see, it's pretty shaky, right? It's going all over the place. So if we were to put this through a model, we would get something like this. Unfortunately, the quality is not the best, but as you can see, it is very stable. So, all right.
Oh yeah, I like it.
All right, so let's talk about some applications for our product right here. We know how significant drones are for the viewer experiences at sporting events and concerts. Well, we could use Stabilis to further improve the drone footage, and we could also use Stabilis on these low budget drones that don't necessarily have the high tech equipment to stabilize depending on its movement. You can also use Stabilis in cinematography. You can now become your own director, basically. You can help, you can make your home videos much more stable. Vloggers could use it on a low budget to create vlogs because they're always moving around. So you can use Stabilis to make stable videos while they're recording. You could also use it in the film industries. Producers and directors can use it to create more enhanced products with a lesser budget. Next slide, please. So what could we have done to improve our product? Well, we could have made a real-time stabilizer. We could have we could have stabilized the videos that it's recording in real time. We could have had a phone app. We could have made it portable where everyone can use it and can be used on any device that has a camera. And finally, we would also look to improve our data set. Currently, we looked at our data set, we can see that it doesn't account for many moving objects, or it doesn't account for various types of lighting, and we'd like to improve that as well. All right, we're open.
Great name, by the way. That was a really good beginning and thoughtful how you put it together. So that was great. I see something like this as an app, like you said, that you develop that people could use on their own. But I see it as something TikTok or YouTube would buy to implement on their platform at some point. I'd really encourage you to think about going further with it.
Thank you.
That's cool. Yeah, here your data set, you can crowdsource your data set. I mean, anyone with a phone here can give you shaky videos to build up your product. So what is the product exactly?
The product is a stabilizer.
No, I know, but how do I have to get a login account, a membership, and then I upload my file, my video file, and then I get a new file back that it's been stabilized?
Yes, precisely.
Okay. All right, so maybe a demo, maybe you could clarify how a user would use it.
Okay. So as of currently, we have not been able to finish the endpoint that we would be able to enter the video. Mm-hmm. That is the only thing, because like I mentioned, we were running these epochs for 300 and they took absolutely forever. Right. And then also we were hitting financial limits.
Right.
So we
this is where Blackstone Launchpad can help out with the AWS programs.
Yeah.
And also, in your presentation, it's okay that it just has slideware. I mean, and a demonstration to give the audience an idea of, oh, that's how I would use it. Yeah. Good.
Just like use Canva and make what it would look like when you do put it together.
Oh, like an example of the UI.
Yeah.
Okay.
Yeah,
Yes.
exactly. Yeah.
It doesn't have to be fully built.
Yeah.
To add on to your crowdsourcing statement, it's hard to crowdsource just because we need an example of stable and unstable. So they would have to have a stable machinery as well as being able to shoot the unstable footage.
Oh, that's interesting. Yeah, because you need to build that AI behind it to teach. That's okay.
Yeah.
Interesting.
One question, I heard that you were struggling between two different models, can you go in detail about that?
Yeah, so we originally started stable diffusion, but so for the first 80% of our working period, we worked on stable diffusion. But unfortunately, when we got the code running, we got we tried to get it running on AWS. Once we tried to get it running on AWS, we reached those financial limits. So the current one we tried to do, it was MLP3 2x large. The GPU was running out of RAM. So it was hard for us to try and train that. So then we couldn't go up because of financial limits. So we couldn't get a better GPU with more RAM because of this financial limits.
Just out of curiosity, how much do you spend on AWS?
That is confidential and something we'll talk to Biggie with later.
Comment?
177.
Do you guys use somebody's game computer instead?
Sorry?
No, we ended up also.
Sorry, what was the question?
You could just use a gaming computer.
That's what I ended up. So when we hit the financial limit, just to show there's not overlap. We did hit the financial limit with the diffusion first, almost, but we did end up. I actually made sure that it was working on my gaming computer first, and then we were in the end able to. Now that we knew it would work and there weren't as many issues, we were able to move it on AWS. But my poor computer was harmed in the process of this.
So I'm still stuck on this crowd getting your own data.
So
because you could probably do it with just scenery. It would be more difficult with people in it because.
All right, so these data sets, as you can see, this third data set, it has people in it, so these people are moving, but then.
So maybe what it is, it's a movie, and then you film the screen of the people moving stable, and then you purposely, unstabilize this. Maybe you could collect data.
The only problem with that is that we have to zoom in so it can shake up and down, right?
That's a lot.
Which could make us lose data.
I see.
So it is a bit of a problem getting data for this.
So it's not a matter of actually the input. You have enough data to work with. It's the problem of the AWS and the output.
Yeah.
Yes, those are the two hardest. And then as you can see from our example, the hardest thing I was having focus on was the person himself. But like I said, that was less of an issue with the data set and more of we need to just train it for longer. So.
That's good. Yep, very good.
Thank you.
That's your
everyone. We are halfway through watching our teams present, and I have a special treat for all of you for staying through this. We are about to have a pizza and snack break. Yes. So hey, listen up. I think that food might not be allowed in this room, so we should ask Biggie and ask some other people to clarify, but for now, before we get a confirmation, let's keep the food out there. But it's all out there so we can go line up. Richard, so we've done those four. Well, we've done meat. We have 18 total and we'll have to. Stabulous. I call it that was the sunriser. Yes, I just talked with Sri Tej and they need to go next. Sri Tej, don't be kissing. There's two remaining people up here. And they're going to present, and I'm hoping I saw them. I'm pretty much is there anything else?
Yes.
Oh,
Just missing out the. Give me a second, because I was just.
actually, I'm not going home.
Where you going?
I'm not going home.
That's good.
Wait, I should have.
What? Yeah, I'm gonna send you.
Going to go to West Indies.
Yeah, you're gonna send you.
It works now. Do you want me to filter? Yes.
Right now. Now,
Absolutely. Robbie, what should the threshold be? I pulled right about 0.1, so it doesn't matter. Wait, what? I've set 0.1. 0.1? Yeah, look at this. What's the typical, what's the average? Look at this. Wow, that's so great.
It's not squeaking. It's stage fright. That thing's not on right now.
No, yeah, after Christopher, Christopher's next, yeah.
Because recording the entire pizza right there.
Christopher's next. Hey, relax. Next is Christopher. You told why?
Bro, change it, man. We need to go.
No, yeah, but it's not quite ready yet. I need 5 minutes.
We have 5 minutes. That's the thing. It's
Yo, I was thinking we could look up some data like related to developer productivity we use as part of our pitch.
You should look up how long people spend on Slack.
Yeah, exactly.
How much time spent on Slack per person per year?
Trying to
I
find
look at my average time on Slack. It's probably usually 15 hours.
like trying to find
The answers. Wait, what model do you actually use for classification? So, we use stuff like next time I'm just just try it on site, like, or just do a shot. Yeah, we looked at it. Hey, Flask. Oh, Flask.
Yeah, she said this team was going next.
No, that's what I wish, I wish Creative had like an auto, you don't have a lot of realize it. Yeah. I wish I did. You can always talk to the guy. You talk to the CEO. Talk to the guy, the CEO. It's pretty chill. See, this was everyone. See, no, it's all in a group. All in a group. All he wants to like share his technology. Oh.
Yeah. I see configuration. Yeah, are you sure? Oh, is there a glitch? Let me check. I need to test some code out. I keep getting the wrong page. Oh, also, we're probably going to do the presentation on my computer because, like, mine's the only one where the presentation line. Oh, okay. Wait, what's the first one? Is it perfect. Okay. Wait, so I'm from here on. Yeah. 600 is. So please do. Wait, which one's it? I was put it into the
I would stop there. Like that's when I would do that, and then that's it.
Okay. This is where they do you want to wait? No, actually. Okay, it works now. Everything works. You wait. Oh, jumping. You made it like you can.
It's not that easy.
Oh,
Yeah.
It works. It works. Is it the same endpoint? Yeah, same endpoint. Okay. Yeah, probably really my polarization. You want to have the like I'm sure I've never lost a lot of issues. Somebody else. Actually, I'll do this before the panel. So, like, what program I actually do? Right?
Oh, that's exactly what I was looking at.
Yeah. But it doesn't say.
Yeah, it doesn't. That's the problem. I couldn't find anything on that.
Let's say like a 32% of the lowest in your time.
Well, you could like twist this to say like, oh, on average, developers spend only 32% actually ranking. That means the rest of the time is spent things like meetings, security issues, testing,
Oh, no, this is.
He said whatever you wanted. No filter.
So this one's like how long I spend is just
He doesn't give a Google research, Google reading, reasoning of it, just type it.
Yeah, so it's just literally 2 hours, which means
The other 6 hours of researching or having to dig to get other shit. That, oh wait, can we make our own graph just to calculate the percentage of the data is?
It is possible, but
That's
you
like,
can contact my.
it's 2 out of 8 hours.
You need to do those. Time graphic is to increase. Like time graphic.
No, we use like, we use Western application. So not yet, database of people who have stuff.
But I guess I think they can. That shows names or simply fields.
That's so amazing, their fingerprints.
Okay, yeah, that is true. That's definitely.
No, they need to like launch a real thing. How are you make this out of factions? You know that help thing?
Just toss it in there, see what they do.
Yeah, we have need to do this and we will have more resources to do it.
But it's still, how does it work?
So yeah, this is faction, I mean, you're doing I mean, you get data sets somehow, and factions not just one semester, it's throughout like the entire it's done, yeah.
Everybody get their food, snacks, and everything. Good shit. Boss, good? You look stressed.
Oh, I am stressed.
Look at it, go home, but we're all gonna watch your stuff. It's okay, are you coming after that? I have to make that announcement after party, the sus one. It's okay, I bought more Martinelli's. Brian, don't give me the judgmental look. I've been preparing all day for this. There's like 2 to 3 different flavors. There's an ice cream milkshake, there's an ice cream. There's one that's got the strawberry part, and then there's but y'all did really well. Person's happy. I'm trying to have y'all present again next semester, with some startup people, or something. But we'll see. We'll take some videos. I want like a poster or some shit like that. Okay, we're already did that as well. ACS classes. AC features. You want to know last? We get off food. So true. You're not wrong. It makes no sense to have somebody sit there for 2 hours and not eat.
No, that is a genuine. That is
And like for us, like I dropped money on it, but we actually had funding. You know, build a page. That's kind of the benefit for us. But we had $1,000 donation. That was my win. So that we could do way more. I just chose not to because I wanted to do a photo shoot for $700. You know, we're all dressed up as like mafia. Next semester. But it's $400. I don't know how it's good.
There's a couple friends that do photography. So, there's like one with the
Well, we have a person. Well, we have photographer Mario on the team, 2 TikTokers, and then 2. Well, I just have a person in mind. She knows how to do the. Oh God, is this recording still? Well, it's mine. It's mine. Well, this might be Wow. Oh, geez, Rick. That's. Well, ice cream. I'll give you ice cream. Have that. I lost. Oh, nice. Wait, is it? Yeah.
So, who funds these parties? Yes. I don't know. I cannot get Thank you. Oh, you're welcome. Thank you. Good job. Yeah, really weird. I don't know. Okay. I think it's just. Everything must be. August.
The way that she does everything is correct.
We asked you.
Yeah, that's the greatest tool. That's because all
Didn't already know that. Like
Okay, I'm probably a bad because first of all, the ones in the door.
yeah. So what you know what I mean? I might have been like very
I think we'll try to go for the players. It's not really an they don't pay.
All right, we are ready to resume. Excellent. So everything looks ready? Awesome. Excellent. All right, I'll get their attention then if y'all are ready. I'm just curious, do you by chance have That's okay, no problem.
Let's talk after. Yeah, that's okay. All right, let's talk after, yeah. Cool, thanks. Yeah.
All right, everyone, may I have your attention, please? Thank you all for coming back in here. We are about to resume our AIM mentor projects presentations. So at the beginning of this evening at 4:30, I introduced to all of you guys 7 mentors, but we have a bonus mentor, Shritesh. When I say bonus, that doesn't mean that he just suddenly became a mentor. He was a mentor the whole time, but we're just introducing you to him now as a surprise. So here is Shritesh's team, and they are going to go next.
Can I pull out this? Yeah, do you have like a lap? I'm a. I don't have the HDMI connector. No, we'll connect to this website. I'll just do it. Here, can you just type this link? Are you in the AIM Slack? I am in AIM. Oh, okay, then the link's already there. It's already on the Slack. It should just be in the general. Yeah. This one? Yeah. Yeah. They're just present and show whatever you'd like
All right.
Hello everyone, so our project is restocking interest in investing in the stock market, and this is a tool to help build foundations of wealth. And so our team consists of Pranav, myself, Avinash, and Vinay, who couldn't make it today. And our mentor is Shritesh here. And so today we'll be talking about the problem, the solution, the execution, and the demo of our project. So how many of you guys invest in the stock market or have invested in the stock market? So these numbers conclude that 60% of Americans are scared to enter the stock market, and this is due to one main factor, which is fear. And people are so they don't want to risk their money, you know. So the stock market is made of money, and money does not grow on trees. So people are scared to put their money in because there's a lot of things that can factor into it, such as stock volatility and uncertainty around the stock market and lack of education about investments. So basically, inexperience is not a good thing. And 85% of money managers underperform on annual benchmarks. And according to CNBC, most new retail investors nowadays use Robinhood, and most Robinhood investors usually follow. According to CNBC, the large increases in Robinhood users are often accompanied by large price spikes and are followed by reliably negative returns, meaning that most Robinhood investors tend to follow performance and hype in a way, because it draws attention to the most active stocks. And that is not a good thing, because they follow this mentality called herd mentality, which is basically they all follow one thing that one person is doing, and that this is really bad for new retail investors because it can lead to price bubbles and an unsustainable way of investing. And this is a volatile way to invest, and it takes away the analytics of investing. And so our solution was to create a bot to help give accurate stock advice. And we did this by compiling data and understanding the stock market. So we got our data from Yahoo Finance API. And to understand the stock market, we had to learn about stock metrics, indicators, and important patterns to help predict trends in the market. And we did this through deep reinforcement learning. But what is deep reinforcement learning? It's goal-oriented algorithms to maximize reward using reinforcement through penalization and rewards. And what deep reinforcement learning does has an agent, action, environment, a rewards function, and a policy. The agent is a thing that takes actions navigating through an environment. An action is a set of all possible values an agent can do, and the environment is the world that the agent moves in. The rewards function measures the success or failure of that so-called agent, and the policy is the strategy that the agent employs.
So why exactly did we use deep reinforcement learning? And we did that for two reasons. One, it's very, very, very useful in financial analysis. That's because deep reinforcement learning automatically optimizes key parameters and models. Meaning, there's so many different stock metrics and so many different stock indicators for every single stock. How do we choose the best one? That's exactly where deep reinforcement learning comes in, and that we take advantage of that. Moreover, alternative data and large, big bulks of data sets have also paved the way for deep reinforcement learning to be implemented in financial analysis. Just because there's so much data and we have to figure out the best way to use it. Last but not least, deep reinforcement learning is really good because deep reinforcement learning bases its actions off of alternative models to maximize cumulative reward. And in our case, that cumulative reward is our total profit. Moving on, how did we build our bot? That's exactly where we're going to go into.
Oh, never mind, it doesn't work.
So we did it in three steps. One, we did a lot of research and development. Starting in, we had little to no knowledge about the stock market, let alone artificial intelligence and deep reinforcement learning. So we had to spend a lot of time learning about that, learning how to code it, but not just that, learning about how the stock market works. Secondly, after we've learned it, we have to build it. We built this and we have to go through different models and go through different indicators, whichever worked best with our model, and experimented with it and also use different data sets. Last but not least, it's all about training the model to make accurate predictions for the future. So again, we did this with a very, very simple approach rather than going all hard and heavy, guns blazing, So first, we decided to get our data from using, as Zane mentioned before, using the Yahoo Finance API. And secondly, this Yahoo Finance API gives a whole lot of data for every single stock. So we had to refine that and come down and bring down the total amount of ratios by looking at many different ratios like price to earnings ratio, the total profit margin, the total payout, and many other factors. Using those factors, we put that into our A to C model, which I'll cover in a bit, to come up with profit. So again, as I talked about how the Yahoo Finance API gave us a very, very large data set. And it was very important for us to just bring that down to actual usable data. But we also ran into a problem here. It's all about compatibility. A lot of these different APIs like Alpaca Trading API, Yahoo Finance, and the FinRL package that we used, all of these needed to be on the same version. Essentially, one like Yahoo Finance API would only work in compatibility with Alpaca only on one version. So finding that was very difficult. But the next part was to parse through the relevant statistics, and you can see examples of how we had to calculate the ratios, the cash ratios, and all these other ratios to help us train the model with the most recent data. So then, using the most recent data, we could use that to accurately predict the future. So, bringing us to the model. What is an A2C model? An A2C model is an advantage actor critic, which is a type of reinforcement learning that essentially gives you rewards based on your actions. An actor is basically me in an environment. As Zane talked about in the deep reinforcement learning, an actor is the person who does something in the environment. And the environment is exactly like, it punishes you if you do something wrong, but it rewards you if you do something right. That's where the critic comes in. The critic is what calculates what is good and what's bad. It calculates whether or not an action should be rewarded or penalized, basically teaching the actor what path to go down. But obviously there's a lot of different paths that the actor can go through, which is where the advantage part comes in. A2C model is very unique insofar that it calculates a policy gradient to come up with a total amount of reduced variance of outcomes to make sure that overall we're going down the right path. And that's why the actor, in our case, takes the best reward. Next, it's training the API, training the model. We had to first create the right environment. So we had to put in all this, how stocks work initially and create our own environment and compute the optimal rewards function because we're trying to shoot for the total best amount of profit but the least amount of moves, like buying, selling, holding. Last but not least, we had to teach the model the three basic principles of the stock market: buy, sell, and hold. And last but not least, we had to run the ATC model and train it. And as you can see, this is another big part of our build process. We have to go through a lot of different basically testing to figure out which type, which gamma, which momentum, which time steps, and what indicators we have to use to come up with the most accurate, most rewarding function. You can see on the right side, we had a lot of different varying profit margins or rewards, but we ended up settling for the total best reward. Again, looking through some of the main obstacles that we had to face. One, as I mentioned before, was finding compatible versions of the various packages. Secondly, was refining the HTC algorithm. And you can see we had to go through a lot of time and effort, running all these data models, which would take a very long time. Last but not least, it was learning how to use and implement this into the cloud and creating an endpoint using AWS SageMaker, and finally putting it on the website. That's the bread and butter. We ended up receiving 124% return of investment on our trading bot's annual return of a 30 stock portfolio, which I know, 124%, that sounds like a lot, right? I put in $100, it's gonna give me back 24. Hey, that's only on a very small margin. 124% is very good because A, it shows that a computer is able to make these decisions to end up being profitable. So now we're gonna go on to the demo and the implementations. So starting off with how we implemented, we started off very basic with Google Colab, but we decided we want to run things faster. So we switched to the cloud, Amazon's AWS SageMaker, and we figured out how to create an endpoint from that and put that on our website. And just, this is our model and the algorithm compared to the benchmark, right? This is, for example, Boeing. And over a full year span, you can totally see that our algorithm was able to consistently beat up the benchmark. And also another example of this is Nike. And I just want to point some things out. Initially, our algorithm took some time to learn, just like everybody else. But at the end of the day, we still ended up beating the overall benchmark. And this is a real implementation.
Sound on the I'm not too sure. I can try, but I don't know if it'll work properly. Is there a way you could send a video? I could play it offline. Let me check. I'm not too sure. Yeah, no, I don't.
Okay, if you can get the audio, it's fine.
Okay.
Do you want to play?
I'll speak. So starting off, this is our website, and what we did was we made a drop down of all the different stocks that we could use, and
yeah, go ahead.
Yeah, give it a second. So my friend Avinash, who's also in our group, is joining us online, is gonna click on the stock button sometimes. Come on. There we go. So now you can see that essentially what we want to create is a tool that people could use, that they could look at a stock and say, what is this stock going to look like? And we really wanted to put that on our website. And you can see here that our benchmark compared to the green line took a little bit of time. And again, it's all about trial and error when it comes to ATC, right? So again, at the beginning, it took a very very big gap, but slowly but surely, that gap was very it was closed down, and we ended up beating the benchmark. And yeah, if you guys are more than feel free to try it yourself and make some money while you're at it. Yeah. Last but not least, the future, right? Obviously, we've spent a lot of time on the back end rather than making the website look all pretty. But there's something that we really want to implement in the future. One would be output the action reasons, right? Telling the user why they pick these stocks. That education is really essentially what we're trying to solve in the first place, right? Educating the user on giving a reasoning on why they chose the stock and why the stock's moving that way. Secondly, we wanted to be able to analyze news articles to see whether or not a stock is popular, which could really determine how the stock's going to go. Obviously, like if we wanted to, we could also like add a daily stock pick, where like the user could sign up for a newsletter that could give them daily stock advice. And last but not least, we just threw that in because we're very, very money hungry. We can potentially put in a membership-based paywall, so only members could like access our the data and the bot that we've created, so only they can make money. And we can also make money from advertising. Thank you very much for listening, and now we're
The stock market, I've heard described as a second order chaos, in which it's something that's very unpredictable, but that interacting with it makes it further unpredictable. How have you accounted for this when building your AI?
So again, there's something called outliers with the stock market, right? Every once in a while, you're gonna get a stock like GameStop that just goes crazy out of nowhere, but it shuts down, right? The beauty of artificial intelligence, and but not just that, the HC model that we've been able to come up with is it's able to account for those outliers. It's able to give. That's what you saw with the benchmark. It was like sometimes it was off, but at the end of the day, it still was like it still beat our algorithms was still able to beat the benchmark. Which we'd like to think that it's pretty accurate when it comes to like solve.
Sorry, that was not my question. So, second order chaos. The changes that you make to the system, interacting with the system fundamentally changes it each time you interact. I'm not concerned about other people causing chaos, or rather your model causing chaos.
Okay. So again, that chaos is like if every single person, the 60% of people, 60% of Americans who aren't in the stock market, they just randomly go in, right? But even then, we use up to date like data, right? So let's just say we say a stock is going up on one day. The next day when you run it again, it might go down. Which means that like what you're talking about, how like the second order chaos, right? Yeah, that thing I contend that I don't think this is happening.
Guys, did you use data from 2021 to training model?
We used, yeah.
So how do you know that your model just didn't learn about the trends in 2021, and then when you ran the other stock, it didn't just follow the trend?
So when we initially trained the model, yes, we did use 2021 data, but then as we talked about, we used the Yahoo Finance API, and it gives us up-to-date data. So like essentially, like we can get up to like yesterday, whenever the stock market closed, we can get data out of that.
No, I understand, but that's a problem because if you use new data, the model just learns how to recall something that's already seen. It's not predicting any future behavior.
I think it's yes, you might be right, but I think the overall thing that we're shooting for here is that the more that the model itself or the agent itself learns in this case, the more likelihood that it's just going to be able to predict that.
Yeah, I'm just critiquing your 124% return rate because it's not a correct number unless you train the model on everything up to 2021 and you test it on 2021 with a model that never seen that data for any stock for any planet. Because unless you can say that, it's not a real number.
I understand. I appreciate it.
Yeah, I think you guys are trying to solve world peace in predicting the stock market, which is very ambitious, so I commend you on that. Yeah, I guess my question relates to his earlier one. I mean, so this is essentially agent-based modeling. I don't know much about it, but is there some risk of just there are other companies, other algorithms that also do auto investing and probably run by the same logic as you're training your bot. So won't it just converge to what else is out? Like this decision making will converge to what is already out there and then cause that herd mentality that you are trying to avoid to begin with.
I think, okay, so first off, contrary to like whatever kind we've shown here, the main goal here we're trying to solve is education, right? Again, like one of the biggest future plans is to show why we believe the stock is going a certain way, right? It's teaching people what indicators to look for, et cetera, et cetera. So rather than, again, that's why we avoided just putting money in and like the bot being automatic with the stock market. We want to like help educate the people how the stock market works. That was the bigger goal here. But yeah, I mean, obviously the idea that like it's going to converge into one big, artificial intelligence bot, that's obviously there. But I think we were shooting for like about 60% of Americans that are fearful of going to the stock market just because they don't know what is going on.
I just have a quick question. So, like, being one of those more hesitant investors myself, is like, if I'm listening to this robot, how do I know that, like, no, it's not going to be hackers or like a safety measure that y'all have like implemented, and to make sure that, it's not like just spitting me back something that's like, invest in GameStop, like, that kind of stuff.
Well, first off, it was like the way that we take it from our model to our website. We're using an API from Amazon AWS SageMaker to like the website. Right? So I guess, we haven't really looked into security measures because I don't know who's hacking into like a sophomore year AIM project. But you're right. Obviously, there's like a fear of that. I think the best way that I can answer that question is that we already have pre-trained models, right? That is not really gonna like take other people's input. We just take ours.
So if your goal is to educate the 60% on investing, not necessarily telling everyone to invest or put their money somewhere on a stock, then you definitely have a lot of good future work ahead of you to like create some UIs and sort of gamify and have lessons and like what indicators to look for, and then like quiz the user, and that would be fun and interesting and useful.
I completely agree, but we just didn't have the time for the manpower.
Yeah, well, you've got future work to do, so
Thank
it's
you.
good.
Thank you.
And for the money hungry comment, I just want to say, I think I did a competition, grand prize is $25,000. So.
I'm hungry for that.
So, yeah, it's a good, entry level, next step into something like that. Cool.
Awesome.
Okay, yes.
Yeah, you can just come out.
Coming up next, we have Chris's team. Yes.
Okay. Yes. Are you already on the stream? Just do whatever you want to do on here and it'll show up. Just handle everything on here and you're good.
Hi, we are Lang Portal, and my name is Joshua Matthew, and I'm joined by my team here.
My name is Zane Abbott.
My name is Atman Shent.
My name is Brian Hargreaves.
My name is Rahul Gandhi. And today we present to you an easy-to-use translator that can also be used for education purposes. So communication is an important part of our society. Currently, there are over thousands of languages that prevent people from communicating with each other. So there's two main solutions to this problem. We can either first use a translator to communicate with other languages, or people can learn the language and just communicate that way. Lang Portal tries to combine these two solutions into one single service where users can translate and also learn the language at the same time.
So the motivation, why is this app useful? So basically, it can improve communication between all groups of people. So say you go to Spain or Mexico or any Spanish-speaking country. Well, you have the translator right there to help you learn the language as you go so that you can become better at it. Or you don't even have to go to Spain. You can gain access to all kinds of languages, and we can do this really quickly. And also, we have a text-to-speech function where you can just hear the audio and then learn the language like that, pick up how to say certain words. And we also have a dictionary function. So basically, if you just highlight a word, you can see what that means and learn words from the definition so that you build your vocabulary on the language. So we have multiple services like this.
So this is our pipeline for our project. So we first started by acquiring a data set from the Hugging Face library. Then we used Google Colab to train our data set. And then we deployed it onto AWS SageMaker. And we connected it to our front end made by React through AWS Amplify and Lambda.
So how did we exactly start this? So we started off with the KDE4 data set to get our data to train the model with. And then we used that input text and broke them up into tokens of smaller size to feed into the model. And then those tokens were converted into IDs that the computer can better understand. And those IDs, those tokens are translated individually. And then they're grouped back together at the end based on the language or the grammar. So for example, if you have like the phrase "the boy," then they have to go together as "le garçon." So that grouping phase takes care of that so that common phrases are put together.
Let's talk about transformers and how the model works. So this is our transformer model. Basically, we have an input that goes into our transformer. Inside of the transformer, we have an encoder and a decoder. So the encoder will take in the inputs, and then it'll send those inputs to the decoder, which will then make predictions on what the phrase will be saying based off the inputs. So we use the blue score metric to basically measure the accuracy of our model. We pulled the pre-trained model from Hugging Face, and before we fine-tune and train the model, we had a blue score of 46. Then we had trained the model and achieved a score of 54. What does that mean exactly? So in this chart, as you can see, 50 to 60 is very high quality, adequate, and fluent translations, and it's right here on the scale. So it's very fluent compared to the rest of these other metrics right here.
Alright, so for the front end, we made a website using React.js, and in that website, we essentially used Material UI to make all the buttons and text boxes pretty, and we compiled those, or I should say transpiled them into readable JavaScript for web browsers using Webpack, the Webpack CLI. We also used Amazon Transcribe to use the text-to-speech and speech-to-text feature. And of course, we hosted it on AWS Amplify. So now, in order to communicate with our model, we used a series of Amazon Web Services. So starting with Amplify, where our website is hosted, we then use an HTTP host method, which will send our input to the Amazon API gateway. And so our input looks something like this: inputs Apple, and we will essentially route that using the Amazon API gateway to our Lambda function, which is a static code that is hosted in AWS. And that code will call our model in the SageMaker endpoint, and it will essentially predict what our input will be in Spanish. And then, as you can see, it'll give us back our data, manzana, which is apple in Spanish.
So our biggest strength is our dictionary, since we are more of a learning platform. And also, we provide a fluent translation backed by our blue score. And also, we are accessible at any time, anywhere, through either anywhere you can have Wi-Fi. And also, our biggest weakness is that currently we only have English to Spanish. However, this is opposed by our biggest opportunity, which is we can scale it at any time and include any languages we want. And also, sometimes some words like ice cream, our model can't pick up and translate properly, but this can also be countered by improving our AI model and turning using a much bigger data set to translate, have a better score or translation. And our biggest threat currently is Google Translate. However, we are able to compete with them through our dictionary, because we are more of a learning platform where users can highlight a word and see the direct definition of it in direct translation in Spanish, so we can easily promote learning different languages.
if you're using a phone and would like to test out our model, you can use this QR code. If you'd like to use it on your laptop, it's very useful to type in that link.
Okay, so let's look at the website. So the site adds input English to Spanish up. So let's take the symbol word like hello. As you can see in transfer to all of you, the game we can see to us.
Hola, mundo 66.
No. Now let's try a little bit of a sentence. Maybe just now. Hi. I said that. And now the only voice when this feels to me, then it means to be on the definition from the other, learn from there. Let's one more. I tell you, let's take the famous Dark Mirror. I am your humble quote. Dark Mirror, and begin again. Highlight, see each word's definition. So soy or I, going back to our slide. Now let's talk about the future. Well, not the dog, but our future of running for we are hoping to have more languages on book. So if you want any other language or go anywhere else that's not Spanish or English speaking country or just learn another language like French or German, we can help that with ability being able to be able to switch the input language model. So as of now, you only do English input, but hopefully in the future we can have we can put Spanish to English as well. Make expand our learning aspect having more visual learning style or game something that help the user understand and make the learning experience more interesting and hopefully turn design into an app and mobile app. Thank you. Any questions?
Good job. So really neat demo too. I was trying it out on my phone and I thought that was great, how you could highlight the words and see the definitions too, that's fantastic. What made you decide that you wanted to create this type of translation software?
Oh, I guess that's me.
Yeah.
I'm not supposed to talk. Just to mention. But I had to come up with the project, and I am half Mexican, so I'm supposed to be good at Spanish. However, I'm only half good at it. Our model is actually way better than me. So I just have a lot of relatives that I need to communicate with, and it's always a barrier to hang out with them or even call them. So I wanted to have actually make something that would help with that, and also try and learn Spanish along the way. So yeah, it was all that. They did all the work.
Quick question, so did Google Translate not work for you?
Well, yes, but ours is cooler.
Okay, but the Google Translate, is there AI in that translation? How do they?
They use I looked that up a long time ago, so my explanation will not be good. But they use a very, very advanced version of kind of half AI and half user input from actual fluent speakers. So that's why they're able to achieve a very, very high level of translations, is because they use not only the AI model, but they integrate human input as well.
That metric blue, I learned something new. That's very interesting and good to use that. Cool, thank you.
I thought you I was gonna say, I thought you had ice cream as your weakness, like a personal weakness, not a translation weakness. But anyway, okay, great.
Yes.
How do you handle the translations for like videos? For like your app?
See, currently, just like he said earlier, Google actually takes in user input. For example, when you translate, they actually have a thumbs up or thumbs down button, so where you can rate the translation. So we're not at that level yet, so we can't. But that is part of our future expansion. We hope to be able to also use an AI model and also user input to improve our model, part of our scalability.
You had a third top.
All right. Next, I believe is Rami's team. Yes. All right, Rami's team, come up.
How you like the new Pokemon game so far? It's pretty good. It's fun, I guess I should say. I shouldn't say it's good. Yeah, it's just fun. It's much better. Oh, right. Just, are you on the link already? The streamer? It's in the AIM side. I'm not here to talk. I can't talk. You can if you want to. No. You know what? Yeah. I'm sitting here. And then just present. Oh, you went from the side. Oh yeah. You just do everything on here. Cool.
All right, everyone. Over the last 10 weeks, me and my team, we worked on a project called Search Source AI, an AI assistant tool to find the best answers for GitHub issues in the least amount of time. My name is Iqbal, and this is my team.
I'm Eric Harris. I'm Eric Schultz.
I'm Rami Ismail.
So legend. The mentor. So I'm pretty sure everyone here have encountered strange bugs, issues while using open source libraries. And to find the answers, we have to go and look through the unintuitive documentation just like this. It's extremely hard to read, and it takes a lot of time from developers. Next. So after doing some research, we found that 75% of workday is spent just doing research, which means the average developer is spending 2 hours just coding. So out of 8 hours workday, they are just coding for 2 hours. It's insane. So what is the problem that we are targeting here? Open source libraries are confusing with convoluted issues on GitHub. Their documentation is extremely hard to read and time consuming. And we are trying to find something where we can find the answers to these GitHub issues in the least amount of time. So what is the solution?
So we decided to build an engine implementing AI to search through the GitHub issues and then integrate that into a developer's environment. That'd be more of a future thing, but in general, starting off just grabbing from GitHub issues without having to spend the time searching yourself through those GitHub issues and leaving your environment to try to go search through multiple pages and cut down on that 75% research time of the workday. So the tech stack we used, obviously GitHub issues, because that's where a lot of the data is going to be searched. Amazon S3 buckets, Amazon SageMaker, and you guys have gotten to spiel multiple times today about AWS Lambda for APIs and the associated cloud software from AWS.
Oh, okay. So we had to process our data somehow. You can't just like copy all the information off of GitHub and throw it in your model to train it. So we had to pre-process all that data. We had to vectorize everything. We had to find a tokenization model in order to be able to process all of the issues to actually be able to vectorize it. And then we had to map each token to an integer, and that's for our actual sentence transformer. But for our actual model, so we took all of the GitHub issues and we did some data augmentation on it to help expand the amount of data we actually had to work with. Then we used multi-label classification as well as neural semantic search. We use 2 different models because sometimes you have different tasks you want to complete. When it comes to multi-label classification, maybe you put an issue on GitHub and you want your organization to be able to classify all of these issues so you know what to get to. So we have to be able to classify these issues as they come. And then neural semantic search is you need to be able to put an issue in that you're having and see if there's other people that are having the same issue. That way you can actually solve it. And then these are all the things we use. So PyTorch, Pinecone we use as a vector library or vector database. And then GraphQL to actually grab all this stuff from GitHub issues, Python, weight biases, Hugging Face. So
as Eric mentioned, in the augmentation step, we tried to get a more accurate data set by introducing variants into our data that we're going to train, because we don't want it to all converge and have end up having a similar issue to the stock thing where you're just converging on something. But so we introduced some more variants into our data set in the pre-processing.
Okay, so NLP augmentation, yeah, pretty much is just the ability to, instead of saying this is very cool, being able to add different words that kind of mean the same thing, but can actually augment your data in different ways. So this is the bidirectional encoder, and the reason for this is you don't always. You don't always.
These out loud for myself.
You don't always want to be able to just read your inputs from left to right. So bidirectional allows you to actually read from both directions. We can embed different text and then actually
map each thing to an integer and send it out. Yeah. But this is our actual model for our second. This is kind of the pipeline for our second model. You take in a question, so let's say the user types in their question. You're going to vectorize that query in order to be able to search through our vector database. And it's going, so the question's going to come down to the retriever. It's going to vectorize it, and then look in the database and say, hey, what other instances of this kind of vector do you have in there? And if it has similar context, it's going to send that back to the retriever. It's going to send the query and all of the similar documents it found to the reader and actually output an answer. So neural semantic search, it uses a deep neural network, so powered by an information retrieval system. So it actually is powered by the documents that it finds. It doesn't just generate text, but yeah. Has very high dimensionality. It was like 1,024 vectors. So every vector or every query has over 1,000 vectors attached to it, which was quite a pain for my PC to actually use sometimes. But for the demo, so we use Gradio, which is a little demonstration platform that you can use for your machine learning models. We didn't have time to actually make our VS Code extension. Because we want this to be a tool that people can use alongside their coding. It takes a lot of time to Alt-Tab to Google Chrome, type in whatever you want, Alt-Tab back, copy whatever you need from Stack Overflow. So we want this to be kind of like a code along thing that is actually in the IDE you're using. But you can see this part, this is the classification. So if you classify some issue, and the best part of this is you can set some kind of threshold. And you'll see in just a moment, but let's say I'm having some issue with like Flask. Flask is a server end rendering framework. Let's say I'm having some issues. So Flask login is broken, won't sign in my issue. And let's say you put this on GitHub and your organization wants to be able to classify this issue so that its developers know that they need to be able to work on it. So it's going to do its thing, hopefully. Okay, no. It was doing it when I was sitting down over there.
Of course.
Sometimes if I leave it open too long, it doesn't like that. Well, while it's getting started again, so it has to load the model every time that I open up the actual Gradio, and so sometimes it can take just a moment. But while it's actually loading, talk about the future plans.
Oh yeah. So as we mentioned, we were trying to originally, the goal was to create a VS Code extension integrating this AI to grab from GitHub issues or the FAQ, what have you. But we did run out of time. We had limited personnel to do this, so this is all of us. But I'm pretty happy with where we got. So the future implementation would be the VS Code extension, maybe a Chrome extension, because there is now VS Code on the web and there's all these online platforms. I'm not really sure how that would work, being completely honest. We haven't done the research to integrate into third parties that are hosted on the web instead of locally because there's permission issues and whatnot.
So you can see this is kind of like the tags that you can use, and I probably set a higher threshold level when I was actually using it, but a developer could come through, they could add their issues, and then say, okay, well, this is a good label. You can kind of hit like, yes, oh, I would like this one, no, don't add this one. That way you can better optimize workplace efficiency. And then for the actual FAQ, let's say, I don't know, I always struggle to think of an FAQ question. I don't know, how to import a library inside of Python. So it's going to vectorize this query and send it to our vector database and try to see, well, how do you actually do this inside of Python? And it'll take just a moment. Right now the model's running on my laptop, which isn't very fast, but nice. So you can see it gives a little code output import library. It can actually determine if you're asking for code or if you're asking for like a word answer. So if you're asking for like a text answer, and it kind of outputs accordingly. But yeah, so that's our actual model. Continuing on.
Yeah, so this one has endless applications. We can use it for any discussion boards from Stack Overflow to any school or college-related education boards as well. And any question answer forum that needs a better application for search engines.
Especially internal tools for companies, they can integrate this into all that internal tooling. And for onboarding or anything else, instead of a person trying to go to 3 desks over to ask a manager about how this specific issue or what's going on or some weird esoteric language issue, with their internal tooling, you now have this implemented within. So that's a definite application of this.
Oh, we talked about future steps. But yeah. You want to talk
We can
about
talk about this.
Okay. So some options we had, we lost half of our team members over the course of the project. So as you can see, it's just the 3 of us. And ironically, all of the tools that we used had terrible documentation. So it increased our time for development a lot. And then, yeah. And also code is notoriously hard for generators to generate because there's very specific ways that compilers are meant to interpret code. And for a computer to output that out is very difficult. So with the semester time constraint, it was a little difficult, but with more time and especially more training on the model, especially focusing on the giving it functions and output that it can actually use, it'll be a lot better. And then lack of exposure to complex technical details. This is something that only gets better with time. The more issues you feed it, the better it is at responding to them. So as people use it more, it'll definitely improve in efficiency. Thank you.
By the way, the email and website didn't work.
No.
Just here for it.
Another application is all these software as a service kind of companies. Their FAQs and help desk is all like FAQ driven, and you have to type in your question and then long list of answers that are irrelevant most of the time. This could definitely help.
Yeah, for sure.
So,
And
it's a
it's
big market.
Yeah, it's very easy to fine tune a data set on, especially if you have like a certain company and they want something done a certain way. We could fine tune this on whatever their specific information is, and it would better respond to that company's requirements.
Yeah.
It's a really good presentation.
Yeah. Good.
I mean, if you're successful, then we need less developers, so you're not gonna have.
I know, right?
Here.
That's what I was coding myself out of a job.
The other thing is, a lot of companies store majority of their information in Slack.
Well, we can make extension or app that connects us to Slack, just like VS Code.
Yeah, it's like absolute majority of corporate knowledge these days is stored in Slack.
But eventually Slack is gonna reach a point to where as data grows within, a company investing in Slack, they're gonna have to invest more to get more data to be able to see messages further back, and eventually it's just gonna, I feel like Slack is gonna go away for something that's better. When that's gonna happen.
Data storage goes down every year, so it still takes to itself, so just buy more hard drives.
Awesome.
All right, we have one team left. Ryan's team.
This is it, right?
Really? Okay, perfect. I'll talk to you later about it. I'll let you know.
Hello, we present to you the Bot or Not 420. Our team consists of Ryan, our mentor, Hamza, Nehan, Sergio, and me, Vaishnavi.
So as many of you know, Elon Musk recently bought Twitter, and one of the biggest disputes during the whole negotiation was the actual percentage of bots on the website.
So why do we care to find out like why a tweet is bot or not? Well, there's a lot for bots existing in Twitter. There's a lot of data theft that occurs. If you don't have an existing VPN, they're able to get to your passwords, your social security numbers if it's on your phone, and your credit card number. There's also a lot of financial loss that occurs with bots on Twitter. There's in one instance, there's like a $1.2 billion loss in cryptocurrency. There's also, it acts like a virus sometimes too. It exploits your system. And there's a lot of talk going on right now about public opinion manipulation due to bots, especially when it comes to Twitter and such. So these are all very important to figure out, like if a tweet or an account is bot or not. And that's why we're focusing on tackling that today.
Our solution to the bot problem is, ironically enough, a Twitter bot that, per the request of any user, will examine a tweet and predict whether it was tweeted by a human or a bot. The way to access this assessment is as easy as finding a tweet you're curious about, as if it were tweeted by a human or bot, and then you reply to the tweet by mentioning the @butternut420 and using the hashtag UTD.
How are we able to do this? Our first step is to find a data set. So if we want to go find a data set, but we face many roadblocks, and you're just not talking about those roadblocks in the presentation. Then we went on to create a machine learning model, and we use two libraries for that: SQL and CoreML. And lastly, when we built and trained the model, we integrated this into Twitter API to create a Twitter bot.
So as Mayan said, we had some troubles finding an accurate data set because the data we were looking for was in the form of human and bot tweets, but we couldn't find any, and the best we could find was a cable data set that had Twitter IDs and labeled them as handled by a human or bot. So we built from here and obtained access to the Twitter API and wrote a Python script that would obtain the most recent tweets tweeted by the IDs on the cable base. So we built our own data set of human and bot tweets, and then we proceeded to do some data analysis. And you can see here some of the differences between the human tweets and bot tweets. The word maps basically show like which words have the most frequent use on the tweets. And there's also a difference in the length of the tweets as it regards to words. As you can see, human tweets are usually longer, like not usually, but you can see that it's most likely that a longer tweet belongs to a human data.
So as I said before, we use two different libraries. For version 1, we use sklearn, multinomial name-based classification. This name-based classification pretty much puts a weight on a text as data we give it based on sentiment. And the output of that sklearn model was on 72.2%, and we were not satisfied with it. So we went on and created a machine learning model using Apple's vision library CoreML. We use transfer learning and dynamic feature extraction to take the features and run over 25 iterations, and we got accuracy rate around 82.4%. A major roadblock with this CoreML model is that an Apple model could not run on Windows machines. So what we did is we took this model and converted it into a TensorFlow model, which would work cross-platform.
So as Daniel mentioned, we use the Twitter API to read and write tweets. One of the biggest roadblocks we had was actually referencing the original tweet in the thread and the tweet ID aforementioned. And luckily in the Twitter API, there was a parameter called conversation ID, which we used to resolve that issue.
For deployment, for version 1 name-based classification, we used Heroku because it was cheap. It was around $7 a month to deploy it, but the CoreML model does not support Heroku, so we use AWCC2 to deploy it. It was also quite expensive. It was 68 cents every hour, so now we're just locally running it for the demo. A way we can make money out of this application is licensing this technology to social media, to companies who do marketing on social media accounts. And this application can go through their social media posts where they're offering a product or a service and automatically report those bots and spam text in their replies in their social media accounts.
For future improvements for our current model, we're planning on changing up our model a little bit by using k-means instead. K-means, what it does is it takes a certain tweet, data set of tweets, and then using complex patterns of vectorization, complex feature sets for vectorization, we take the tweet, turn it into a number, a data point, and put it into a graph. You see those two bold points? Those two bold points are considered as k-averages, so the averages between each cluster. And this is definitely a lot more adaptable, and it'll definitely help a lot better when it comes to more ambiguous tweets that get passed in. Because if a data point gets passed in, somewhere in between, k-means helps figure out which one is closest to either a bot cluster or not a bot cluster, and sees which one would be better, and it would definitely increase our accuracy rate from 82.4 to a higher number. And we're also planning on incorporating using a fine-tuned deep learning machine algorithm later on into making this accuracy rate a little bit higher and helping everybody.
Okay, for the demos.
Okay, so we're gonna take you through to a demo real quick. Nehan is going to go on his Twitter account and mention the bot using the hashtag UTD, like we said earlier.
So I find the
Okay, so he's gonna mention the account, use the hashtag, and within seconds, if not immediately, the bot or not account will reply to his account with an assessment, which is public and everyone can see like what our account predicted, even if they're not the ones that did the request.
As you can see.
So can you give us narrative? What are you doing? Do that again.
Oh, so let me do this again. So
Yeah.
I find a feed, right?
Yeah, you find a feed.
I tag my account we made, that's just Twitter bot.
Okay.
And to actually run it, we have to hashtag AIM-UTD for the instance.
Oh, okay. And it's running off your
It's
computer
local
right
now, yeah.
Okay.
I press reply. Oh, never mind, I already used that. Yeah, let me find this.
Yeah, and then it's reply.
Yeah, I did. So, reply. It's on the first automatically, so I go to your books. I go to my account. Yeah, give me a reply.
Oh, there's the reply.
Yeah.
This is a human. Oh, that's cool.
And if the bot detects that it is in fact a bot, we also implemented an auto report feature into it.
Oh, cool. Thanks. That's awesome. Wow. Good. Is it only in Twitter that this works?
Right now, it's Twitter, but we can implement this in any social media platform as long as it goes API.
How do you, okay, this is so, you guys know that I'm so not technical. How do you get an API?
You
from-
request it for
and
So
it's just,
Twitter's API, their level 1 access is available to anyone. You just have to sign up and then write some code. We actually had to apply for elevated access because to actually send tweets, you have to have they don't want just any random bot sending out tweets. So we have to go through an application process for that. And then from that, we were able to get a couple more endpoints to actually make our bot work.
Have you tested it on some obvious bot accounts?
Yeah.
and it's accurate?
82.4%.
Okay.
We have plans to increase that number, increasing our data set, getting better ML models. Obviously, yes.
Given recent changes to Twitter's leadership, do you anticipate your model existing in the long term?
Yeah, we don't believe that the API is going to be anytime soon.
Yeah, a lot of Twitter accounts are using their API, so.
Yes.
Have you thought about pitching this idea to Elon Musk?
We have actually tried to apply for internships through this. So we actually DM'd one person. His name was @GrowingDaniel. He was looking for people to hop on Twitter, but between the day that we messaged him and then within 24 hours, you're actually fired from Twitter. So, yeah. However, we would be very interested in joining the Twitter team.
Good to meet you.
Yeah, that was great. You guys Wow, I learned a lot tonight. This is great. Good presentation. Yeah. Good job. Yeah.
I think so. Well, that was all 18. I'm so thankful that everyone here came and stayed. So let's see if we have any closing remarks. So AIM happens every fall and every spring. So if you are interested in being a part of AIM in the spring 2023, either as a mentee or mentor, then let us know. The application for mentee will come out in the next few weeks over Christmas break probably. And
yeah, thank you so much for coming through. We will have applications open on kickoff. So keep your eyes open. We'll have it the first week of school. I'm so proud of like all the teams. I know some teams left and all, but you know, it's tiring. Everybody's got homework and stuff, but like y'all did amazing. I've been watching y'all for the last 8 weeks or 10, right? Just grinding and people who don't know code, people working on cloud. I'm telling you, we'll tell you how to put this on your resume properly. I guarantee you at least one company will want to interview you. That's one thing I know for sure that's happened. So at least, even Mark has had at least one interview, right? See, at least one, right? And that's the point, right? You're working on these technologies not only to learn, but also get a job, right? Yeah.
Okay, so how do I put it on my resume?
Well, we will talk at another event. We'll tell you the format and be like, oh, we use these technologies. We did this impact, this metric. Basically, Microsoft.
What's
The resume. Oh, she's a resume bot. Exactly. We'll link it just for you. But yeah, thank you so much. Follow us on Instagram, TikTok, and whatever. But yeah, thank you so much. Y'all have a great evening. And shout out to the judges and the mentors. Sorry, thank you so much for staying. I know it's a long time. But yeah.
Great.
Thank you so
I learned so much. Thank you.
Oh, yeah.